Okay, this video is going to be looking at how we can solve a three-variable system of equations. So something that is important to note is that if you have three variables, you need three equations. When we only had two variables, we only needed two equations. So this method is going to be looking kind of the old school method of doing it, using elimination to get rid of our variables here. I will say if you have access to a higher level technology such as a TI-84 and you understand matrices, there are some other ways to solve a three variable system. But even doing that means that you need to understand the basics here. So that's what we're looking at is the basic way of how we could go about solving this. So just like with the two variable system, one of the biggest things we want to do is eliminate variables by combining our equations. So here we're going to do that, and we're actually going to eliminate one of our variables. It could be x, y, or z, so that we end up with a two variable system that we can solve. So looking at my equations to start, I can see that I have negative z, positive z, and 2z. Because this will take very little manipulation to make these cancel out, that's going to be the variable that I choose to eliminate. You could do any of them, but for all of the other combinations, I would have to multiply multiple functions to do so, versus here, I'm going to do just a little bit of manipulation. So for goal one, it says just choose two, whichever your two starting ones are going to be, and eliminate that variable that you've chosen. So I'm going to choose A and B. So x plus 2y minus z equals 4, and 3x minus y plus z equals 5. And here we're just going to go ahead and add our functions together. So that gives me 4x, 2 and negative 1 is just y. My z's cancel out, which is what I was going for, and then is equal to 9. Now I have just two variables. Well, in order to solve a two-variable system, I need two equations. So I need to do this process again, and I just need to choose a different combination of my functions. That means I have to choose C. C has to be chosen at some point. And then because A is already negative, I'm going to choose that one. So I'm going to start with C, 2x plus 3y plus 2z equals 7. In order for my z's to cancel, since this is positive 2z, this needs to be negative 2z. Right now it's just negative. So to get that 2, I'm going to multiply my entire function by 2. That gives me 2x plus 4y minus 2z equals 8. So I multiplied every single one of these by 2 to get this equation here. Now I can see that my z's are going to cancel because they're the same value with opposite signs. I'm ready to go ahead and add my two functions. That's going to be 4x plus 7y equals 15. So now I have two separate equations that have the same variables, x and y. So I have a two-variable system that I can go ahead and solve. These do look similar with the 4x. That's just happenstance here. The biggest thing is that I have two different equations. They both have x and y. So I'm ready to go ahead and solve those. So that's kind of our goal 3 here, is to look at, now that you've created a two-variable system, go ahead and solve that out. See what you can do with it. So I'm going to grab those equations. 4x plus y equals 9. We noted that they already both have a 4x, so to make that cancel, my elimination here, I'm going to make this entire function negative. So it gives me negative 4x minus 7y equals negative 15. And now I'm just going to solve for x and y here. X is going to cancel. This gives me negative 6y is equal, well, 9 and negative 15 is positive 6. I can divide both those by negative 6, and I get y equals 1. So here I've solved for one of my variables. I'm actually getting pretty close. Now that I've solved for y, I know that all I have to do is plug this back into either of these to get my x value. So I'm going to take 4x plus, instead of y, I'm going to put 1 equals 9. Solve this out. 4x is equal to 8. So x is equal to 2. At this point, I've done everything I can with the two-variable system. I have my y, I have my x. Well, that original variable that we eliminated was z, so I need to just plug these in. I can choose any of these to plug it into in order to get my z. I'm just going to choose a because it's the first one. So x plus 2y minus z is equal to 4. My x value I know is 2. My y value I know is 1. I'm solving for z. That gives me 2 plus 2 minus z is 4. 4 minus z is 4. Well, the only way to make that work is if z is equal to 0. And then there you have it. The last step is, depending on what you're looking at, I like to write these as an ordered triple. So in the X, comma, Y, comma, Z format, that really shows what this would look like if we were graphing these. So my X value is 2, my Y value is 1, my Z value is 0. So this would be my final answer here. So once again, overarching goal is choose a combination of equations to eliminate a variable. Choose a different combination of equations to eliminate that same variable. Once you have your two variable system, go ahead and solve for the two that you know. Plug them back into an original one to get your third variable. And there you have it. That is how we can solve a three variable system.